All right, we have here a system of linear differential equations. It's written in our matrix form. We have y prime is this matrix times y, and that's how we want to write our linear systems of differential equations. We want to show that this function, this vector function here, is a solution of this system. And the idea is to do what we did back in chapter 1 when we first did this for single differential equations. We look at the left-hand side of our differential equation and the right-hand side, and we want to see that these are equal for this function, that this function satisfies the differential equation. So let's look at the left-hand side. That is y prime. So I take the derivative of this candidate solution. The derivative of cosine of t is minus sine of t. Here we have a plus 1/2 sine of t plus 1/2 cosine of t, and here it looks like we have sine of t minus cosine of t. So I just took the derivative of each of the three functions in this vector valued function, and I have y prime is equal to this. That's the left-hand side. For the right-hand side, it's matrix multiplication. We want to see 1, 0, 1, 1, 1, 0, negative 2, 0, negative 1, times y, right? It's a times y for the right-hand side. So times cosine of t minus 1/2 cosine of t plus 1/2 sine of t minus cosine of t minus sine of t. We will not have systems of three differential equations that we need to solve in this course. By doing a system of three differential equations, I'm showing you kind of a more general example. If you need to do this for a system of two differential equations, it's just one step easier because your matrix here is a 2 by 2 matrix and your vectors are length 2 instead of length 3. But all of the mechanics are the same, and the idea of what we're trying to do is the same. So let's go ahead and do this product. We have 1 times cosine, so cosine t, plus 0 times this, which is great, plus 1 times this, which is negative cosine t minus sine t. For the next line in the product, we do the dot product of the second row with this column. So that looks like cosine t plus 1 times this, so minus 1/2 cosine t plus 1/2 sine t. And then our third row dotted with this column is negative 2 cosine t plus 0, and then a negative 1 times that, so that changes the signs, plus cosine t plus sine t. And the question is, did the left-hand side and the right-hand side match up? So if we take a look here, cosine minus cosine goes away. We have a negative sine of t is a negative sine of t. Here we have a plus 1/2 sine t with this plus 1/2 sine t. And then a cosine minus half a cosine gives us a half cosine t. So that matches up as well. We have a sine of t minus cosine here. We have minus 2 plus 1, so that's a minus cosine there as well. So the left-hand side and the right-hand side match completely, and this is a solution to the system of differential equations.